Hi everyone. I'll be going through 10.1, 11.1, and 11.2 in this video. We're starting out with roots and radicals. So we have this notion of a square root we're going to talk about first. So basically, a number is a square root of another number a if that number squared equals a. So for example, the square root of 9, so the square root of 9 is 3 because 3 squared is 9. That's what this definition is saying. This is just a particular case of that. We have this notion of principal square root. So when we have this symbol used, it's called a radical sign. We're only talking about the positive case, because notice I could have said that the square root of 9 is -3, because -3 squared is also 9. So it's true that actually 9 has two square roots. There's +3 and also -3. But the principal square root, like if I said the square root of 9, that symbol there means I'm just talking about the positive or the principal case. So that would just be the 3. But if it's written out without the symbol used, like if it says find the two square roots of 81, well, 9 and -9, because 9 squared also equals -9 squared, and those both equal 81. Sorry, I realized I'm just writing out of the screen here. So 9 and -9 because 9 squared equals -9 all squared, which both equal 81. If the question were find the square root of 81, that would just be 9. So that would just be the principal root. All right, so let's see example 2. Simplify each of the following. Keep in mind your calculator is great at simplifying square roots. So if I go square root, right, this button right here, and then I'll type in a 16, and this is 4. So this is 4. And just because, it doesn't really ask me to explain, but the square root of 16 is 4 because 4 squared is 16. That's what this is saying up here, just in general. For the next one, so what I'm doing is I'm looking for if this equals a number c, then c squared would equal 100 over 64, right? Whatever's inside, that's what I'm trying to multiply or square to. So this would mean that c times c is 100 over 64. So I'm looking for something times itself that equals 100 over 64. So c must be 10/8. In other words, 5/4. If you're wondering how the heck that just happened, feel free to use your calculator, square root, and then press the fraction. 100, scroll down, 64. All right. So -√9, this essentially means -1 times the principal root of 9. So in other words, I would have -1 times 3. In other words, -3. So I could definitely type that in as well. So negative square root 9, -3. All right, on to page 94. So a function, a square root function, here's a general square root function. So basically we're letting x go from 0, 1, 4, and 9, and we're just taking the square roots of those numbers, right? The square root of 0 is 0, the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and then plotting those we get these. There's nothing on this side, right? There's no negative values there. We can't have a negative number in a square root. Okay. Let's look at example 3. We're just finding the function value here. So I want to find f of 3 in this case. So I'm replacing x with 3. So square root, I need to multiply before I subtract. So this would be 12 minus 9. This would be the square root of 3, in other words. So there would be a point on the graph of this function, 3 root 3. Let's try another one. So g of 0, this case, minus root 7 times 0 plus 4. 7 times 0 is 0, plus 4 is 4. So I have negative square root of 4. In other words, I have essentially negative 1 times square root of 4. So negative 1 times 2. In other words, negative 2. Okay. So here's an application of a square root. You can use the square root to find the distance between 2 points. So what it says is if you have points x1, y1 and x2, y2, that the distance between those 2 points will be the square root of the square of the differences between x's and then added to the difference between the y's. So what I'll essentially do is call this my first point, x1, y1, x2, y2. So the distance between those 2 points would be the square root of x2 minus x1. So 2 minus negative 1. And then I need to square according to the formula. And then plus y2, or 3 minus y1, which is negative 3. And then I need to square. Once you have that set up, you can plug that into your calculator. So I'll start with the square root, parentheses, 2 minus negative 1, end parentheses, and then square, plus 3 minus negative 3, end parentheses, and then square, press equals. This is the distance, 3 root 5. Okay. So technically, here's a technicality. When we are simplifying, so if I have the square root of something squared, that should actually technically simplify down to absolute value of a. What we're going to do going forward, though, is we're going to assume that everything that's being squared is non-negative. So that will be reason to not worry about absolute values. So although this detail is technically true and important, we're just going to push it aside for now. And anywhere we have the need for absolute values, we're just going to assume that whatever was input was already non-negative. Cube roots, so just like square roots, cube roots or nth roots exist. So instead of looking for something times itself twice, a cube root, we would be looking for something cubed. So something times itself 3 times to equal a. So if I have like the cube root of 8, this would be 2 because 2 times 2 times 2, in other words, 2 cubed is 8. So what we're doing here is we're looking for something times itself 3 times that equals negative 8y cubed. So if I have the cube root of, so to make a negative 8, I can use a negative 2. To make a y cubed, I'll use a y, and then I'll cube outside. When I have the cube root of something cubed, those operations actually exactly undo one another. So we would have just negative 2y, which is the cube root of this. Part 2, this is the fourth root. So I'm looking for something times itself 4 times that equals 81. On your calculator, you can access fourth root. So here's the square root button right here. Behind there is the cube root. So if I go shift square root, then a cube root pops up, but this is a fourth root. So I would actually need to go over here. You can see maybe back there. So I'll go shift this button. So that was shift and then this button here. And I can type my 4, scroll inside, type 81, and I get this 3. So this is 3, and just to explain, this is 3 because 3 times 3 times 3 times 3, in other words, 3 to the 4th is 81. Okay, so on to this one. So the fourth root of negative 16. So what this would mean is that I'm looking for something times itself 4 times that equals negative 16. So C needs to be the same number. So maybe we think, oh, what if it's negative 2? Negative 2 times negative 2 times negative 2 times negative 2. Is that equal to negative 16? No, it's not. This would be equal to positive 16. If it were 2 times 2 times 2 times 2, then this would be equal to positive 16. So is that equal to negative 16? No. So both of these are positive, actually. So this is imaginary. So I'll just leave it that way. Okay, on to 11.1/11.2. Here we're going to be graphing quadratics. So a quadratic results in not a straight line, but in these arcs, these what are called parabolas. Every parabola has this important point called a vertex. So this would be the maximum, this would be the minimum. So if your parabola is opening up, such as this one, you're going to have a minimum. If it's opening down, such as this one, you're going to have a maximum. So in terms of graphing, this vertex is a great point to first find. There is a form, this is called vertex form. And if your parabola is written in this form, you can quickly find the vertex. What's nice about finding the vertex first is all the other points happen symmetrically around that vertex point. So if we start here, we can kind of use symmetry to fill in the rest of the graph, and I'll show you that in a minute. Okay, so not all parabolas have x-intercepts. Notice this hypothetical one, its vertex is here, it's opening up, so it would not hit the x-axis here. So this one would not have x-intercepts. This one over here, if its vertex is above the x-axis and it's opening down, this one would have these two x-intercepts right here. So depending on the orientation of the parabola, it may have x-intercepts or it may not. So let's try one. So example 6 says, graph the quadratic function. It says find the x-intercept, state the y-intercept, give the equation of the axis of symmetry. Okay, so what that formula was saying is if your equation is written in this form, then you can quickly read the vertex. The vertex will be right here. So we take the opposite of what we see there, and we take the same as what we see there. So notice if it's negative h inside, then we took positive h. If it's positive k outside, we did take positive k. So for this one, I'm looking here. So the vertex, that special point, it'll be at the opposite of -1, so +1, and then it'll be at the exact same as +4. So this is our vertex point. So what I'll do is I'll come down here and plot that. So 1, 4, right here. So something else that was being said on the previous page is if you have an a, so this number out front, if a is negative, then this thing will open down. If that number out front is positive, then this thing will open up. So we have a negative case, which means that this one is opening down. So we have our maximum here, and this thing will be opening down this way, which means there for sure are x-intercepts. So I'll go ahead and start the x-intercepts now. Okay, so to find an x-intercept, we let what happen? So we let f of x, which equals y, equals 0. So I'll plug in a 0 on the left, and then I'll have negative x minus 1 all squared plus 4. I need to solve this. So subtract 4. I have negative 4 equals negative x minus 1 all squared. Divide by negative 1. Right, I'm trying to isolate the thing that's being squared so I can apply a square root. So I want to get x. What I have right now is something being squared, so I'm going to apply the square root using plus and minus. So plus and minus the square root of 4 means plus and minus 2 equals, on the right these things cancel, and we just have x minus 1 left over. Then add 1. So I'm getting 1 plus and minus 2 equals x. In other words, our solutions for this, which are the x-intercepts, come from taking 1 plus 2. So I'm getting 3 equals x, and then 1 minus 2. So I'm also getting negative 1 equals x. So we have x-intercepts at 3, 0, and at negative 1, 0. So I'll go ahead and plot those. So 3, 0, negative 1, 0. The problem also wanted us to find the y-intercepts. I said intercepts, but really they're all will only be 1. They'll be exactly 1. So to find a y-intercept, we let x equal 0. So I'll have f of 0 equals negative 0 minus 1 squared plus 4. And you can type that into your calculator if you want. So negative 0 minus 1 squared plus 4. So this is the number 3. So this equals 3. In other words, we have a y-intercept at 0, 3. So there's that point, 0, 3. By the symmetry, everything is going to be symmetric across this line through the vertex. So I know if there's a point 1 to the left of the vertex and that lands at 3, there's going to be a point 1 to the right of the vertex that lands at 3 also. So this problem was asking for intercepts, the y-intercept, x-intercept, and also the equation of the axis of symmetry. So this is that axis, so axis of symmetry. Since it's going through 1, it'll be, the equation for it will be x equals 1. Okay, so there are those things that we were being asked to do here, the graph intercepts an axis of symmetry. I'm going to skip to page 100. So what if the equation is given to you not in vertex form? So if you're being asked to find the vertex and your equation is not in vertex form, you still can find it by doing this right here. A lot of words, but really this is the thing we want. So to find the vertex of this quadratic, we do this. So for the one that I am looking at here, we have a equals 2 and b equals 8. So the vertex of this thing would be at opposite of 8, right, opposite of b, over 2 times 2, and then f of opposite of 8 over 2 times 2. So now I need to simplify this. So negative 8 over 4 is negative 2. So I know that the x component of the vertex is negative 2, but I still need to figure out the y component, what f of negative 2 is. So f of negative 2, I plug negative 2 into here. So this would be 2 times 4 minus 16 minus 1, 8 minus 16. It's negative 8 minus 1 is negative 9. So I'd have a vertex of this one of negative 2, negative 9. Let's try an application. So it says the average number of hours per person per year spent watching television during the late 1990s can be modeled by this function here, where h of t represents the average number of hours per person per year spent watching TV, t years since 1990. Part 1 says, how many hours did the average person spend watching television in 1996? So 1996, since t is the years since 1990, that would mean that t equals 6. So I just need to find h of 6. So I'll replace t with 6. So I have 9.5, 6 minus 7 squared plus 1544. Typing that in. So 9.5 times 6 minus 7 squared plus 1544. So we get about 1,553.5 hours. Okay. In what year was the average number of hours spent watching TV the least? And what was that lowest number of viewing hours? So this is a parabola that will be opening up. So if I can find that vertex, this will be the minimum. Right, the lowest number means I'm looking for whatever that point is right there. So this thing is written in vertex form. So I know for part 2 that I have a vertex of 7, right? Opposite of -7. So 7. And then I have 1544. So in what year was the average number of hours spent watching TV the least? So I had 7 years after 1990. So in other words, we would have in 1997, the hours were this number of hours, 1,544. All right, talk to you guys next time. Bye-bye.